What's up guys, L's Math Tutorials here, back with another math video. Today we'll be going over 4 example trigonometry equation questions for finding the angle value of theta such that theta is that the sine or cosine of theta is equal to something. Now this first example is going to be find angle theta such that sine theta is equal to 3 divided by 4. Now the procedure we're going to do for this question, the first step is the same in all of them. We're going to use the calculator and we're going to use the sine to the power of -1 function on it, also known as the arcsine function on your calculator, to get the theta angle value, or a theta angle value. You will get the theta angle value in this case if sine theta is equal to 3 divided by 4 and you use arcsine of 3 divided by 4, you will get theta equals 48.59 degrees or 0.84788 radians. Now for the rest of the steps for this question and the other questions, I won't be going into detail about radians. Of course, I need to specify that this question, find angle theta such that sine theta equals 3 divided by 4, has an infinite amount of solutions. You can divide those solutions into 2 groups, even though it's an infinite amount of them. These 2 groups of solutions are in the first and second quadrants. Theta equals 0.84788 plus 2k pi, or 0 equals pi minus 0.84788 plus 2k pi. This is because, as I mentioned in my last trigonometry video, the 2k pi is actually just representing an amount of 360-degree complete turns around the graph that are included in the angle. They do not affect the position of the angle on the graph. Even though the numerical value of the angle will be different, its position on the graph is the same. Therefore, its sine value would be the same. Which is why questions like this have an infinite amount of answers. And it's also why teachers are going to put restrictions on their questions. Normally, these questions are going to be restricted from your angle value has to be from 0 to 2 pi. However, there are also times teachers are going to restrict it into a particular quadrant. For example, with this question, a teacher might give you a trick question in it. They might tell you, oh, find angle theta such that sine theta is equal to 3 divided by 4. However, the angle is restricted between pi divided by 2 and pi. This would be a trap question to trick students who only find the first angle value using the calculator. They will use their calculator and they will find 0.4788 radians and they'll put it as their answer, and that answer will be wrong. Even though its sine value is 3 divided by 4, that radian value is not between pi and pi divided by 2. In that case, you would have to take the value of pi minus 0.84788 because its position is a reflection of the original 0.84788 angle on the y-axis. Therefore, its x value and its cosine are different from the original angle. However, its sine value and its y coordinate are the same, which means this angle, it being in the second quadrant and having the sine of 3 divided by 4, would be the correct answer in that scenario. Now we can move on to the next question. In this case, it will be a very similar question, simply with cosine instead of sine. Find angle theta such that cosine theta is equal to 1 divided by 3. Now, once again, we use the arc cosine, or the cosine -1 function on your calculator to find the 70.53 degrees or 1.23 radian values. And once again, you have 2 groups of answers that are technically infinite. Of course, you will have a restriction. Like I said last time, everything goes the same way as last time. In this case, theta would either be equal to 1.23 plus 2k pi or -1.23 plus 2k pi. Like last time, these groups of angles are in 2 separate quadrants and are restricted to those 2 separate quadrants, which is why they are 2 groups of angles. These are the first and fourth quadrants because the cosine value of the first and fourth quadrants are the both going to be positive, which means that 1.23 plus 2k pi being equal to theta and negative 1.23 plus 2k pi being equal to theta are both correct answers, just like last time. Honestly, this question isn't much different from the last question. If you had no trouble with the last question, you will have no trouble with this question either. Now, the next question is find angles theta such that sine theta is equal to negative 0.4. There's a small twist this time. You will use the calculator to find sine theta. However, I do not personally suggest that you use it to find the negative angle value. Don't enter arcsine of minus 0.4 in your calculator. Simply enter arcsine of 0.4 and get your 23.6 degrees or your 0.412 radian. Then you put that into the formula of theta equals negative 0.412 plus 2k pi, making it into the fourth quadrant, because you know that the sine values are negative in the fourth quadrant, or pi plus 0.412 plus 2k pi. Pi plus making it in the third quadrant, where you know that the sine values are also negative. Besides that, everything else I say applies just like before. Of course, there are some ranges where you need to be a bit more specific. If theta is required at the range of 0 to 2 pi, we have, of course, two solutions. K is equal to 1 in the first expression given, and k is equal to 0 in the second expression given. This is because we cannot have a negative theta if the required range is 0 to 2 pi. We cannot have a negative theta because negative is not in that range, which is why we have to add a 360 degree complete turn to artificially boost up our numerical value of our angle into this range. Now, there is one final question we'll go over today. Find angle of theta such that cosine theta is equal to negative 2 divided by 3. This is a repeat of the last negative sine question, simply using cosines. Honestly, I won't go into too much detail here, but the two expressions given for answers will be in the second and third quadrants. Once again, I don't recommend you putting the arc cosine of negative 2 divided by 3 into your calculator. Simply put the positive 2 divided by 3 into the arc cosine expression, so arc cosine of positive 2 divided by 3, to get your 48.2 degrees or 0.84 radians, and put them in expressions that would place them in the second and third quadrants to have your negative values. Everything else I said last time goes for this one as well. Thank you very much for listening, and I can't wait for the next video.